days, you can hardly read the news without encountering some exciting development in artificial intelligence. Deep learning, especially, has shown promise in many fields, such as diagnosing diseases, discovering new drugs, increasing energy efficiency, improving crop yields, or predicting extreme weather events. Most of the applications you read about, though, are just prototypes or proofs of concept, not operational systems. Our world faces many severe problems, in particular from the effects of climate change. AI has the potential to help us solve those problems. But in order to realize that potential, we need to integrate artificial intelligence with other aspects of computing technology. Networking, sensors, databases, mathematical models, computer graphics, user interfaces. We also need to build systems that will scale from prototypes that can only handle a small number of users or a small, limited amount of data, to systems that can handle the demands of realistic storage and computation. AI techniques cannot be used in a vacuum. We need to adopt a systems engineering approach in order to realize the promise of these technologies. This means we need to clearly analyze the problems we need to solve. We need to select the appropriate technologies, both AI and traditional. And we need to remain aware and consider the implications of our systems for humans, for society, and for the environment. This sort of systems engineering approach to artificial intelligence is what CMKL calls AI engineering. And here at CMKL, we want to educate a new generation of AI engineers. Our AI engineers should be able to use this approach to tackle serious issues and produce effective and sustainable solutions, not just headlines or hype. Our engineers need to have a deep understanding of both traditional and AI techniques. They also need to be flexible and creative in order to develop new approaches or adapt existing approaches in new ways. Finally, they need to consider the impact of their solutions on the humans that our computer systems are supposedly trying to serve. So one of the most important attributes of an AI engineer is flexibility and creativity. Unfortunately, engineering education, especially in Thailand, tends to be standardized and rigid. Many engineering curricula have large numbers of required courses, some of which may not be relevant for some students' goals, and very few electives. The most common learning environment will be classrooms, sometimes with 30 or 40 or 50 or 60 students, with homogeneous content that's designed for the average learner. Even now, given research on what effective assessments are, most of the grading in engineering education is done using written exams. We know that written exams don't really tell us what students can do. And finally, in the situations where we do have active learning types of activities like project or lab assignments, they are restricted and limited to the context of a particular course. Because of these characteristics, students all have to learn the same things at the same rate as everyone else, regardless of what they already know. The curriculum structure does not highlight important relationships between different knowledge domains, and projects don't let students make those connections by themselves. Students have relatively few opportunities to incorporate their personal interests or passions into their study. And finally, engineering students, in Thailand at least, work on toy projects. They have very little exposure or opportunity to interact with stakeholders in the real world. We've designed our AiCE program to to try and address some of these weaknesses in traditional engineering education. We focus on competencies, not courses. Competency is a set of abilities, not just the acquisition of knowledge, but the ability to apply that knowledge in well-specified ways. Competency is an active learning concept. Students must solve problems in order to demonstrate competency. We recognize that students have different backgrounds and different interests. The students who can demonstrate a competency when they enter our program are not required to repeat the learning activities that they don't need. Many competencies have alternative assessment methods so that students can choose the type of assessment that best suits their interests and their learning style. Finally, we encourage students to bring their personal passions into their work in AiCE. Because students have a great deal of control over their program and over the activities in which they engage, they can follow their heart as well as their mind. We also take a broad view that integrates knowledge areas. So one project can address multiple competencies, rather than having the kind of pigeonholed approach that you see in traditional engineering education. Finally, we collaborate with external stakeholders to build operational systems, not just toy systems. CMKL partners with companies, with government agencies, and with nonprofits to build systems that make a contribution to real-world problems. And the teams on these systems include students. Students in the AiCE program work on stakeholder-defined tasks to demonstrate competencies in a realistic context. You may be wondering, is AiCE for you? Our program is demanding, but rewarding. What you know is not as important as how you approach the process of learning. In AiCE, you have the power to design your own roadmap to your degree. But as we all know, with great power comes great responsibility. Ultimately, you are responsible for your own learning. To succeed in AiCE, you'll need energy and enthusiasm. You also need intellectual maturity and self-discipline. When you complete our program, you'll be qualified for an interesting, exciting, and well-paying career. But you'll also be in a position to make positive contributions to society. AI is changing the world, and you can help change the world for the better. If this appeals to you, we encourage you to join us.